Hello student, hope you're doing fine. So our next part is the magnitude of a vector. And so what is magnitude of a vector? The magnitude of a vector is the same as the size of a vector. It is the same as the size of a vector, the norm of a vector, or else the length of a vector. That is the magnitude of a vector. Yeah, so if we have, for example, our vector p, we can have our vector p, which is equal to 3, which is equal to 3, 3, 4. So what is the magnitude of a vector p? The magnitude of a vector p mathematically is noted by, or is symbolized by, we shall have p within 2 bars. So that is the norm of vector p, or the size or the length of vector p. How would we mathematically calculate it? We are going to have our p, our vector p. So we square the first component and the second component, we add them together and take their square root. So I'm going to have a 3 squared plus a 4 squared. All of them are under a root, such that this goes to 9 plus 16 under a root, which is equal to the square root of 25. I know we've been told that the square root of a real number is positive or minus, but this is length of something. It cannot be negative. In other words, if you put negative 5 or positive 5, it means you have some other kind of ghosty, a ghosty length or a ghosty size of something. So we take the positive part such that we have this as 5, but because it is length of something, or the norm or the size, it's supposed to have units. For this case, I don't know the units, so I just put the word units and I chill. I put the word units and I chill. So we've calculated the magnitude of a vector. We can go to the midpoint of a vector. What is midpoint of a vector? This is a point that lies halfway the length of the vector. In other words, if I have maybe a vector, a position vector of A, which is OA, because we said position vectors are told in relation to the origin, maybe have there my OA. This maybe it is equal to 8, negative 6. And if I'm told to find the midpoint of A, which is OM, find the midpoint. I'm told to find the midpoint. Find the midpoint of OA, which is AM, which is OM. So the midpoint is simply halfway. It means that my OM, let us make sure it is a vector. We are moving from the origin to a point M. It means my OM, if it is the midpoint of A, it will equal to a half of OA. In other words, it is simply a half. Give me vector A. My vector A is 8, negative 6. Such that we said now this is scalar multiplication. The scalar multiplies each component of the vector. I have a half multiplied by 8 and a half multiplied by negative 6, and still this is in column form, such that this will equal to by 2 ones by 2, 4 by 2 ones by 2, 3. So I have 4 with a negative 3 as my midpoint of my vector, as my midpoint of the vector OA. So we have our next question. Find the midpoint of AB given that A is negative 8, 5 and B is 1, 4. So the first thing to do, we can first convert vector A and B to position column vectors. Position column vectors, we are telling them in relation to the origin. It means my OA as a column vector, and as a position vector it is OA column ways. It is negative 8, 5, negative 8, 5, and then I'm going to have the OB. If I got the OB, so column wise it is 1, 4. So they want a midpoint of AB. So what I'm going to do is first find the vector AB. Let this one be, let let us have it as a vector 2, such that I'm going to have AB. We said, how we define AB? This is movement from A and I reached at B. I get the point where I have reached, which is OB, minus where I am coming from, which is OA, such that I have this as, give me the OB is 1, 4, minus, open brackets, negative 8 with 5. So this is simply subtraction of two vectors. I subtract the corresponding components. So this is 1 minus minus plus 8, and then 4 minus 5, such that this goes to, this will go to, this goes to a 9 with negative 1, such that my midpoint AB, my midpoint of AB will equal to a half the size of the vector AB, so that this is going to be a half, give me AB, we've calculated it as 9, negative 1, 9, negative 1, so the scalar multiplication, a half multiplied by 9 and a half multiplied by negative 1, such that this will go to, this regresses to a 4.5 and a negative 0.5 as my midpoint of the vector AB, and it is as simple as that. It is as interesting and simple as that. So students, our next part is the translation of vectors. How do we translate vectors? And before even we translate, what does translation mean? Translation means if I have an object here and then it moves, all its points are moved and they move the same distance and in the same direction, that is what we call a translation mathematically, that my object has moved through all its points through the same distance and in the same direction. That is what we call a translation. How do we define a translation mathematically? We get the vector of translation, or the translation vector. We get the translation vector, the translation, allow me to abbreviate the vector by V, translation vector, and then the object, allow me to say O. The object, they give me an image which I can say I. The TV, the translation vector plus object, they give me the image I. So if we were to look at an example, so our simple example is that one. We have the very light example that translation T is mapping maps A, which is negative 2, 3 onto A prime. A prime is the image, negative 6, 10. Find the image of B under the same translation. So in this question, we need to first find the translation vector, and then we use the translation vector to find the image of B, which is the B prime. So from, we can say that solution, we can get very happy and say solution, and then we say that from, we know that from the fact that my translation vector plus my object is equal to my image. If I can let my translation vector, be maybe x, y, that I have, such that I can have x, y plus, give me the object. The object is A, negative 2, 3 will equal to my image, which is negative 6, 10. I take this the other side, so I have my xy. If we are to use something simplified, if I take the other side, I have negative 6, 10. Then I have minus, open brackets, negative 2, 3. Negative 2, 3. Such that I can have this as negative 6 minus minus, negative 6 minus minus, that is going to be plus 2, then 10 minus 3, such that my translation becomes negative 4 with a 7. So this is my translation vector x, y. That is my translation vector x, y, such that now I can use the translation vector I've gotten with the vector B to get its image. So if I'm to use the translation vector, So still from the translation vector plus my object, for this case is B, is giving me the image B prime, such that I'm going to have my B prime. I can have my B prime as equal to my B prime, which is the image, as equal to the translation vector, which is -4 7 plus plus the object. The object is 5 4, such that I have this as -4 plus 5, and then 7 plus 4, 7 plus 4, such that I have this as 1 with 11, such that, but then I've been given these guys in coordinate form. I've been given these guys in coordinate form, such that therefore my image B prime is 1 with 11, and it is as interesting as that.